Hi guys, today we will be solving Leetcode 1, the twosome problem. Let's dive into the problem statement. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. Let's take the given example 2, 7, 11, 15, and the target is 9. What they're saying, there are two numbers which is present in the array. As you can see, you may assume that each input would have exactly one solution. So they have specified that there will be only and only one solution. And 2, 7, 11, 15, we have to return the indices of the numbers, not the numbers. Let's say for in this example, it is 2 and 7, which adds up to 9. But we don't need to return 2 and 7. We need to return 0 and 1, which is the indices of the numbers. Yeah, so let's solve the brute force approach first. After that, we can try optimizing it. What we can do, we can traverse the array, whole array. Okay, let's say, let's say we have 2, 7, 11, 15. What we can do, we can go one by one and fix the first element. Then search if there is another element which would be essentially the target minus, let's say, nums of I. Let's take another example. Here it's the first two elements are only our solution. Let's take another example. 1, 3, 9, 8, 11, and the target is let's say 17. Okay, yeah. So what we will do, we will traverse from beginning. In the first iteration, what we can do, we can fix 1, and then we will go on and search for 17 minus 1, which is 16, right? As you can see, there is no 16 in the array. Therefore, we'll go to the second number, which is 3, and we will search for 17 minus 3, which is 14. So there is no 14 as well. Okay, one more important thing, what we can do, we can search from the next element. We need not go to the beginning of the array every time. The first time we searched the whole array, right? So we started from 1. We went ahead and searched every possibilities which can be with 1. So we need not search for 1 again. Therefore, while we're at 3, we will not go to 1. Let's move ahead. For 3, there is no 14. For 9, we need to find 17 minus 9, which is equal to 8. So we can, our search space will be this much. So here we will find 8 and we can return 2, 3. Okay, yeah. So what is the time complexity? Let me clear it a bit. So what is the time complexity? We're traversing the whole array. First time we will go for n times. After that we'll go for n minus 1 times, n minus 2 times. If we add it, it becomes n square only. So we need to optimize the time complexity here, that we are now not using any extra space. So the space complexity will be big O of 1 and the time complexity will be O of n square. Okay, let's move on to some optimized approach. Please pause the video and think of an approach. Okay, were you able to find any approach? Let's verify. Let's try using a hash map. Why hash map? Because we're trying to search a number. Let's take another example, new example. 1, 2, 3, 4, 8, 12, and our target is 11. Okay, makes sense. So our solution is 3 and 8, 11. Okay, so what we are essentially doing, we are fixing one number and we are trying to find out if target minus that number is present in the array or not. So for searching, we are wasting big of n time, which can be saved if we use a hash map. Okay, 2, we can store the indices of each number in a hash map. We can traverse the whole array and store the values of the indices in the hash map. Let's say 1, 0, 2, 1, 3, 2, 4, 3, 4, and so on. Okay, so we will traverse the whole array once and it will take off n time, and then we can store the whole thing in the hash map, and then one by one we will traverse the whole array and we will keep searching this second element for each first element. So for 1 we will search 10, for 2 we will search 9, for 3 we will search 8, and we will find it and we will return the indices of 3 and 8 respectively. Okay, but let's take one example to better understand one more scenario. Let's say 1, 2, 5, 2, 8, 9, 10. Okay, and the target is 4. Okay, so our solution should be 1, 3, right? The indices of the occurrence of the elements, which is the first 2 and the second occurrence of 2. Okay, but if we store it in a hash map, we will be storing 1, 0, 2, 1, 5, 2. Then when 2 comes again, this 1 will be replaced to 3, right? So we will traverse the whole array. After that we will traverse again, and when we reach to the number 2, we will search for 2 and we will get 3. So there we can return it definitely, but we have a better solution which can be done in less than of n time if our solution comes in the first half or in the beginning of the array. Okay, let's say we are not storing the whole hash map on the go, and what we are doing, we are storing the hash map while we traverse the array and find the solution. Let's say when we get to 1, we search for 3, right? But there is nothing in the hash map as of now, so we will not find 3. So we will move on, and what we will do before moving on, we will store the value 1 and the index 0, right? Now during 1 in our hash map, we have 1, 0. Okay, then we come to 2, and what we will do, we will search for another 2, right? But as of now we will not find it as we have not populated anything yet. So we will move on, and before going to the next element, we will store the number 2 and 1, right? After that we will go to 5, we will not find a -1, so we will store 5 and 2. But next we will go to the second 2, this one, and we will find that there is 2 already present in the hash map. So which means we already have 1, 2 which is we're traversing currently, and there is one more 2 present in the hash map. So there we can return the current index, which is 3, comma the index which we got from the hash map, which is 1. We can return the solution in any order as it is mentioned right here. So yeah, there you go. We have a better solution than O of n. Like, it's not exactly a better theoretically, but you can get some edge over other Leetcode solutions, as we will be getting this solution before the end of the array, and we don't have to traverse the whole array, right? Yeah, let me quickly grab the code snippet for you. This is the code for the brute force approach. You can pause and take a look at it. Yeah, we are looping twice here, as you can see here and here, and checking every possible pairs until we find the answers, right? So nums I and nums j, if it is equal to target, we are checking that. And as you can see, the time in this case took a very big hit. It is 3634 milliseconds as it runs in of n square time, whereas the space complexity is of 1 here, so it beats 91% here, as you can see. Let's move on to the hash map approach. Here we are first calculating the second number, then searching for it in the hash map. As you can see, if num2 is in the hash map, then we return the result then and there. But if it is not there, then we go on and put the first number in the hash map for the future references. Like when next we are going to find its complement, at that time we can find it in the hash map and return it. Let's see how our time performed according to our new approach. As you can see, it took only 63 milliseconds comparative to 3600 in the last approach, and here in the top bracket. Well, the space is not so good comparative to before, but it's okay as we are using open space. As we are using a whole hash map, so space will be off and time will be off n as well. Great. That's all in today's video. Thanks guys. Thanks for watching.